Hi, this is a technical unboxing of the Cooler Master G650M computer power supply. Right, I'm going to unbox it, then I'm going to discuss all the specifications, and that's it. Right, so it comes in a packaging like so. It's got all the languages, all the standards it's passed. It's got some marketing information here. It shows you what type of connectors it's got. Shows you there's some graphs here. We have the insert, also describing how to install the unit. Right. This power supply uses a modular design. So let's just get it out here. This is the unit. Okay, so here's the kettle type power plug for the supply. Then there's a large fan here, which is popular in most power supplies now, on the underside. And then here are the modular points that they are advertising. Let's open this wire tie down. Alright, okay, let's count these. So the first thing is we've got the motherboard with the additional here, depending on what motherboard type you have. So that's sorted. Then we have the ATX here. Also, you can split it, also depending on what motherboard you have. Another option, there and there, and there again. Okay. Now the modular design works as follows. Let's open one of the ties here. Each one of these has it's like a five pin, well, there's actually no pin in the fifth one, but it's a 5 shaft connector. It plugs in like that. And on the other side we have the Molex. So on this one we have three Molex. Okay. One of the things I'm not so happy about this power supply is that in normal power supplies it's nice when it's color coded. This is not color coded, so these can go in any way. Three more Molex, and here are the SATA. Okay, so we have 1, 2, 3, 4. That's pretty effective to have 4 on one cable, because you can just hop from hard drive to hard drive. And then the fourth connector here. Also we have 1, 2, 3, 4. So altogether, your SATA power cables, you've got 8. There's 8 SATAs, and the Molex we have 3. That's 6. So we've got 6 and 8 And to unplug these, you just press that down, unplug it. Right. Let's put those there. The screws are over here. Now let's just discuss the specifications of this particular unit. Now it advertises here on the box, the first thing it says it's a 650. When choosing a power supply, I think the most important thing that people are looking at is the power output. Now this is the peak power output, 650 watts. It tells you here with the input it can take 100 to 240, which means it will work in any country. 60 to or 50 hertz, and then the DC output, it's telling you it can do 22 amps at 3.3 volts. It can do at 5 volts, it can do 22 amps, so that's a fair current at 5 volts, that's quite a lot. And 52 amps at 12 volts, and minus 12 volts, it's just 0.3 amps. So we've got the maximum power. On the 5 volt side you can get 120 watts out of this unit, and on the 12 volt it can give you 624 watts. Maximum is 650 watts. It also can reach, it's also got an 80 plus stamp here, so that means that this company that voluntarily tried to meet the specifications of the plus certification, which is a voluntary, it's a non-audited, I don't think it's audited, it's just a standard which says that the power supply can meet 80% efficiency under various loads, 25% load, 50% load, 75 and 100. So that's what this 80 means. It means you're going to get 80% efficiency even on full load. Obviously there's higher certifications like with gold and so on. So that's a good thing. Then looking at the other specs which are on the box, it's got active power factor correction. Now that's also important. It says it's 0.9 typical. So power factor correction just means that under varying load conditions the power supply is able to align the current and voltage to stay in phase, which also improves the efficiency. For industrial machines, for example motors and so on, they have low power factor, therefore they actually become inefficient and the voltage and current are out of phase, which results in the supply current being quite a lot higher. So you will then install power factor correction equipment, usually capacitors, to counteract the inductive reactance and align the voltage and current curves. So it's got active power factor correction. It also input frequency, this is important, it says 47 to 63 hertz. Now why that is important, 47, 63, is industrial or inverters don't always have a zero crossing at 50 hertz, so they often knock out power supplies. So it is good, especially computers, because they're not tolerant of varying frequency. So this is a nice power supply, because if your inverter, and what an inverter is it's maybe you have load shedding or your electricity supply in your country isn't great, then your house may go on an inverter during a power outage. Then the inverter provides you the electricity from either a battery source or a diesel engine or petrol engine. So in that case the cheap inverters are not able to get exactly 50 hertz or exactly 63. So this unit can handle a wide range from 47 to 63. So that's a good feature there. However, I don't anticipate that this unit will be able to handle the trouble of non-zero crossing, because for example you might find on some very cheap inverters that the zero crossing is not exactly at 50%, and then the power supply actually has too much stored reactance, or well, yeah, and then it actually overloads. It actually overloads. Okay, moving on here. These specs are fine. We've got the hold time. Okay, that doesn't name anything. Another good feature is it says it's got DC to DC conversion. This means that it takes the AC, the power coming from the plug, it takes the AC, it converts it to DC, then that DC converted again, probably in some sort of H-bridge formation. And the reason for that is isolation. So say your computer is connected to your household or even in a factory, and then there's a surge on the line. Maybe somebody switched on a large array of fluorescent lights or a motor or so on. The DC to DC conversion is supposed to stop any noise or transients from coming through to the computer equipment. So that is an important feature, is the DC to DC. I don't know how extensive it is. Looking in here, one can't tell. It's just very basic. So that's very important to have the DC to DC. And then the other most important thing is how long is the warranty. Now that's what was important for me in choosing a power supply. The wattage, and just the wattage by itself is not enough. You need to understand what is the RMS or continuous rating of this unit. And there are, I think Cooler Master has a power calculator which works out, if you tell the software what how many graphics cards you've got, what CPU and so on, it'll actually do a power calculation for you, telling you what capacity power supply you need. In general, if you're going to use 650 watts or 600 watts, this would be the wrong one, because then you are running the power supply at its peak and it will not last, and it probably won't even get to 650 watts. That's the other story. So this power supply is recommended, in my opinion, for computer setups that will not go over 400 watts, and on maybe a turn on or a under severe load might go to 500 or 550, but definitely not 650 all the time. I would say 400 watts is where you're safe for this unit, and it comes with a 5-year warranty, and it's very important, because when choosing power supplies, that's what most people are looking at, is how long is the unit warranted for. Overall, I'm going to say this is a nice power supply in principle. The proof is in the pudding now. One has to test it. My only criticisms are, it would have been nice to have color-coded wirings. The modular design is kind of irrelevant. I think that's just a marketing point. You still have to plug them in anyway. It doesn't really improve for me. However, what I do like is I do like the fact that they've put many SATA power connectors on one wire, because that does reduce the mess in the computer chassis space. Alright, thanks for watching. That's the end of the review.